Hello, good morning, everyone. I hope that with each session we can get rid of this coronavirus so that we can hold classes in person. Until then, I will prepare an educational video for each session and send it to you in the class group. We are going to work together on the SolidWorks software for computer-aided design lessons and learn how to use this software with an educational approach. It is one of the powerful design software that will be very useful for you, both for work and for your class projects. Don't worry, our training will start from the very beginning. Please everyone, install SolidWorks 2019 or lower, because SolidWorks is one of the software that if you have SolidWorks 2020, please send me a file from SolidWorks, as I cannot open it with 2019. Therefore, we cannot save from it and save it in a lower version. SolidWorks releases a new version every year. So since I have 2019, we need to stick to that. Please, no one install 2020. Well, let's start. According to all the software guidelines, we have new or open in the file section. We can open an old file in open, and in new, we start a new file. SolidWorks has three main parts: part, assembly, and drawing. In the part section, we model the components. In the assembly section, as the name suggests, we assemble them. And in the drawing section, we create the technical drawings. The advanced features are not particularly complex. Another review will show this. We start with the part. The first time you install SolidWorks and want to open a new file, it will ask you a question in a format like this. It asks which standard you want to work with. The default is inches, but we recommend working in millimeters. At that point, you should select millimeters and set the standard to ISO. If for any reason someone else installed it, they might quickly hit New and click OK, just to test if it's fully installed or not. Therefore, whenever you want to open a new file like this, you can change it from the bottom. There are also ways to change it to default, but that's a bit complicated, so we won't deal with that for now. This is called a tree diagram, and we will do all the tasks in this format. Step by step, these stages are recorded here, and we can go back to the past every specific month to edit our files. Now, let's get familiar with this. We will be working a lot with these two toolbars in the future, and we will also move forward with the surface and some other commands. But for now, we will proceed with just these two so that you can get a little familiar. Let's open a file like one of the students' projects. It seems to be missing some water, and a similar project has been done. If I want to show you with the middle mouse button, when I press the scroll wheel and move the mouse, you can see it rotates. Zooming in works the same way. Wherever I turn the scroll wheel, it zooms in. The mouse will zoom in wherever you bring it. Now you might want to see the front view, side view, or top view. It's not very precise, of course. We have Control 1 and Control 2, which change the views. To have a shortcut handy, I suggest right-clicking in an empty space like this and selecting Standard Views. When you do this, these options will probably appear here or at the top for you. Well, we have enough toolbars up here, but I always place them down here for myself. What do these do? Let's see the front view. It shows you the right view, isometric, trimetric, and dimetric as well, and the main point of our discussion is this normal view, which we will now address.
Alright, let's get started with drawing an object. First, pay attention. Kids still ask me questions. First, select the sketch view. For example, we click on the top sketch view here, and it shows us the front view. We start creating, for instance, a simple line. With every click I make, a line is drawn for me. If I want to exit the command, I double click. Besides that, we can also use the sketch. We call this operation dragging. Right now, I am dragging this point, which means I hold down the left mouse button and move the mouse left and right. This way, we can move these around. Well, to create a volume, we need a closed sketch. See, when we do this, all the points are connected to each other, creating a highlight within this sketch that indicates it is closed, and now we can give it volume. I come here and click on the Extrude feature. When I click Extrude, it asks how much volume you want to give it. For example, we say 70 millimeters. The work is done, but we want to work a bit more precisely. I will delete it. Again, in the top sketch view, you see a series of colors. These colors actually mean that it says underdefined here. The blue color indicates that yes, the sketch you drew is here, and you can add features to it, but its specifications or components are not complete. Therefore, you need to dimension them. For each element you select, some of its properties appear here. For example, it says that its dimensions are approximately 70 millimeters. You can now change it to 80. It became larger, but it can change at any moment. Indeed, this is a crucial step in the process. So, if I want this length of this line to definitely be 80, I go to Smart Dimension, select this line, and pay attention to the mouse. It's very important. I bring the mouse to an empty space, click once, and type 80. The reason I say to move the mouse to an empty space and click is that, for example, if I say the distance from this to this, and I click in a crowded area like here, it might snap to another element behind it, causing issues with your click. Of course, there is no problem here right now, but to prevent this situation from happening, I recommend that you always click in an empty space. Previously, this was black. I had an element here that I deleted. These are called relations or constraints. What kind of constraint was it? It was a horizontal constraint, meaning this line must be horizontal. You see here, when I select it, the dimension remains 80, but its angle is changing. Therefore, I can click on it and apply the horizontal constraint, which will definitely set it to be perfectly horizontal for me. Now, you might not want to make this vertical. If I want to make it vertical, I click on it and apply the vertical constraint. You see the colored pin icon appears here. Whenever you want it to no longer be vertical, you click on it and press delete, so you can give it any angle again. Well, I will make it vertical again. Now you might say, I don't want to make this horizontal or vertical. What should I do? we take Smart Dimension, click first on this line, and then click on this line. A dimension appears for me, and I can specify a certain dimension, for example, 120 degrees. You see that 120 degrees is accepted, and Smart Dimension goes away. But why is this blue still remaining? Even the point is because we don't have a value for this line yet. I will remove the small dimension here and go to it, for example. Whatever is 35 millimeters. This one has a horizontal relation on it already. It just needs to be dimensioned, for example, 65 millimeters. And finally, this is the shape. Now let's see what component is missing. The height here is definitely still not specified. So we say the distance from here to here should also be 65. I don't need to give this an angle, because all its components are complete. This is a rule of geometry. When we draw such a shape with this size and this angle, I can no longer assign an angle to this size. For example, I say the angle from this to this should be. See, a yellow error appears, meaning that such a size cannot change at all. So please don't assign a size to it anymore. We say OK and cancel it. Now if we look at the bottom, you can see here it shows fully defined. All the components of our sketch are actually complete, and the color is completely black. The only thing we need to do now is to give it an extrusion. For example, 50 millimeters. If we want this 50 millimeters to go down, we press the reverse direction button. Well, we still have the front, top, and right views of the same. We can only sketch on a flat surface for now. Later, I am allowed to use these surfaces as well, because they are flat. For example, I select this surface, click on Sketch, and then I click on Normal. Why do I click on Normal? I have a reason for that. Look, for example, I just gave it a slight angle, and now I want to draw a circle. Why did this circle become oval? Or if I wanted to draw a square like this, I see that it actually turned into a rectangle. To avoid this optical illusion, let's use the normal tool to bring this workspace right in front of our eyes, so we can easily sketch. Now let's assume we wanted to draw something like this, and we did. For now, we won't give it a specific size. I go to the feature and click on Extrude, and you can see that we were able to create a new sketch on this surface as well. What is another mistake that most of you make? It is that when you select this page, click on Sketch, and also hit Normal to view, you think you are limited to this blue area. I have told the kids in every class that this is an infinite page, extending left, right, and down to infinity. Therefore, you can draw a circle here, sketch your design here. It doesn't matter. They are all on the same page. From here, we can also give them dimensions. Just as we could select the page, draw the sketch, and actually extrude it. The opposite is also true. What does that mean? It means I select this page, click on Sketch, and I had already set the normal view. I draw a circle here, and instead of extruding it, I hit the Extrude Cut. What does it do? Instead of creating this solid for me, it subtracts from the other one. You know this very smoothly as Boolean operations. You can do it this easily. You don't need to create that volume first and then reduce it. We can come in at this temperature, and I can draw such a triangle. Pay attention, this part of the triangle is not supposed to reduce anything. There is nothing here. It's just empty space or air. If I extrude it, it will be cut. Only the specific part that is involved will be extruded. This way we can reduce something. Now let's take a look at the tree diagram. It shows that you first extruded a volume, then you cut these parts out and created these two. Now we have two extruded cuts. Yes, whenever we want, we can come back. If we want to change its feature, we right-click on the desired option and select Edit Feature. This means that the dimension I provided was incorrect, so I can increase it. Or if I want to change the sketch, I right-click and click on Edit Sketch on the right side. I adjust it so that it aligns exactly in front of me. For example, instead of 8, it should be 50. You perform your operation. And interestingly, I get an error now. It reminds me that we had drawn a triangle here, and now this part has become smaller, so it has moved back. The triangle is still in place and is creating space. You can't reduce something from air, or in fact from a vacuum. So, if you see that this command has encountered an error, I click on its sketch or on itself. I select Edit Sketch, and I say, yes, it was my mistake. It should have had such a distance to be able to reduce it. That's why we ask you to always define it immediately. If I had given an instruction, for example, I would say to set the distance from this point to that point, or from here to there. Let's do this. I remove the Spartan animation and say, it should be 20 from this point to here. Well, it went back again. If we happen to change the dimensions again, for instance, instead of 50, I set it to 30. You see that the distance of 20 is still maintained, and does not change at all unless we go so far into the corner that there is nothing left for it to reduce from. So, the reason I ask you to fully define your work is partly because of this. Of course, this is all experiential. As you move forward, you will understand it yourself. This volume that was based on data, we are just practicing like this. Imagine that we have a complex volume with a very long and large tree diagram. And if we want to go back to the past, you know how many errors you will encounter, and your shape will completely break. So, you mentioned the children talking about extrude and what can be done with fillet. The first thing you do here is set the new period to a full period. Why do this? So that wherever you select, it shows how much it will fillet. You can also change the corner size, for example, to 5 millimeters. You can choose anywhere you want. For instance, I select these and hit OK. Some children make a mistake by clicking on the fillet option again after setting it to 5 millimeters and say 5 millimeters again. Well, if both were supposed to be 5 millimeters in the previous command, why add a new command in our tree diagram? This way, Whenever you feel you've made a mistake, you just need to change one command. Click to edit, and if 5 millimeters was wrong, change it to 2 millimeters. If the size gets too big, you can adjust it. For example, in this case, if the size gets too big, you can adjust it. As an illustration, if the size gets too big, you can adjust it. Up to 12 millimeters you see 22, but it doesn't show me the preview anymore. And if I hit OK, then it's good. We managed to do this no matter what. And now we are going to increase its size. When we set it to 32, it gives us an error saying that this volume is becoming too large and is rounding off, causing some of the features to disappear. This means that our volume is encountering an error. It also suggests selecting one of the smaller options and trying again to make your shape more acceptable, because in this way it cannot be done at all. We say OK. Let's set it to 10 millimeters. Therefore, if we want to take a smaller size, we will use a new command. For example, 5 millimeters. You can see this feature and this feature here as well. This page is such that you don't select everything for 2 hours. Just if you move the banana aside, it disappears. It's called the Show Selection toolbar, which I think came with SolidWorks 2016, or maybe it's older. I don't know, because SolidWorks releases a new version every year. I don't exactly remember, but it's a helpful option, and in our upcoming examples, you will become more familiar with it. Now, with just these 3 simple commands, we can do a lot of things. For example, these 3 commands are essentially our foundation. Let's create a new file. We told the kids that with these 3 simple commands, they can create almost anything, probably over 50 different items. In the community, you can make everything from your mobile phone to its charger, your laptop, remote controls, simple chairs, tables, and beds. You can completely arrange these things with it. Let me see what we should create as an example. Well, let's create a table. It's very important to know from which view to start. I will start from the front view. Let's select the front view. You see why I say we should select it. If we don't select it and try to create a sketch, it will tell you that you must draw the sketch in a plane. In which plane? In which view? Here. You would have to select it again, or choose it from here, and there's a chance you might make a mistake in your selection. So please, let's just follow the same program and use the selection toolbar to create the sketch. I want to draw a table, and I will start from the right view, which is the best angle to begin with. I want to draw my own computer table, which is a profile that I am seeing in front of me. This table has a sleek design with a smooth surface, and I am excited to capture every detail of it in my drawing. I started from the side view, where I draw, and then, from here, there is another profile that supports it. Well, to commence with, I think that's enough for everyone. However, there is a problem now. If I want to export it, you will see that it no longer gives a preview. It asks if you want this or that, and you have to choose yourself. There is a symbol next to the mouse that I don't know what to call it. I open the sketch, and there are some extra symbols in the sketch that we look at. I say, if I wanted both, then this line here is extra. If I want to delete it, I select it and hit delete. Well, it removes all the lines from the side, but we have an option called trim. Let's set it to our last option. You see, wherever it is brought, it can recognize that these two are engaged from a certain point. Therefore, I can bring this. Well, we have created something like this, but I also need to size it. It can't be done without sizing. Let's go to Smart Animation and measure, for example, 220. All of this is about how much we work with Smart Dimension and how to create a shortcut for ourselves. Next to this option, there is a choice called Customize with an arrow. I click on Customize and search for the 5th tab on the keyboard. Because all the simple commands are here, but it can be hard to find them. I search for Smart Dimension. Now, isn't it nice? Let's click on Dimension. I have already set a shortcut for you. It looks like this. I press D. If a message appears saying that D is already assigned to something else, just say it's okay. I want to assign it to this as well. We click OK. Now my left hand comes to the keyboard, and I can easily press D quickly to give it the desired size here. The speed also increases a bit. We provided all the dimensions and the pulley is defined. Now let's give it an extrusion. How much? 8, for instance. You might ask, what is this that you drew? Now they will tell you. I will select the top view of this and say I want to draw a sketch, approximately, in this case as an example. Well, what a sketch. I want to have a table like this. In fact, this surface is on it. Of course, let's not forget that it should be fully defined. I want to replicate this entire volume on the other side. For now, just so you can see, we have drawn a rectangle like this, and we will give it an extrude with a thickness of 6 millimeters. I want a shape like this on the other side as well. While we do have commands like copy, mirror, and move, for now, we want to use a different command. To start here, I need to sketch something. I also need a page, and if I use this page to draw this, you can see that there is a gap here. I just want to point this out for a moment. We will work with it a lot later. If you haven't learned it well, don't worry. In the feature section of Geometry Reference, we can create a new page. It asks for a reference, and I say, this is one of my references, and this is another one. It automatically comes to the center for us. The interface gives us a new surface. So why did I draw this? Because I want to mirror this feature relative to this surface. I click on Mirror, and it asks me which plane I want to mirror with. I say the same plane that I just created. Which feature do you want to mirror? The feature that I created here. Or if I want to select it from the tree structure. This was extrude number 1. What I created, I click to make the shape a bit more refined. I won't delete this plane, and I right-click to hide it for a moment. I move it a little and curve it. Now let's practice. This surface that comes in the middle. See this small area that I select. It quickly brings me here. Notice that the other corners on the left, right, and bottom are highlighted in pink. So if you select this, I can draw the other sides based on it. Let's see what other options there are. The option says again, I need to select all the vertical lines, except for those bottom corners around the table. So for now, I want to make the corners 20 millimeters in size. I can select the surface where I want to create the selection, and it should actually cover all around the table. There's no other option available. I'll set it to 5 millimeters. Even the bottom part needs to be created. I'll select this surface. I've activated the tool, and I'll use the sketch. I quietly go down so that it is exactly in line with this. I drew a circle here. Guys, if we want to perform a mirror, we don't need a surface in the sketch anymore. We need a center line. Where is the center line? I draw a center line here, and another center line here. In fact, I found the middle of this shape. And I say mirror the sketches. Notice the difference. We are currently in a 2D environment. When you see these two marks, it means you have entered the sketch environment. The reason for this action is to specify what you want to mirror. I say I want to mirror this circle. It asks, relative to what do you want to mirror? I say this line. Okay, I click. And you see another circle has been created there. If I move this circle, you can see the other one is exactly mirroring it. I pressed Ctrl to bring it back to its place. I say again that I want to mirror these two circles, and this time from the other one. I created 4 circles, and what should I do? I actually just want to have a little angry expression down here, so that later I can come back to this surface, select it, and say I want to draw a sketch. You see, this time I won't draw the sketch myself. You can use the tool instead. But for now, you are all learning, so don't do these things. It might be better this time not to bother myself with drawing the lines, to mirror them. You see, when I bring the mouse over this circle, it automatically defines the center of the circle for me. I can draw several circles. If I don't draw the center of this circle, you see what I need to do. I hold down the Control key and say, this circle and this circle. I select these two together. You ask how many options come up. Do you want them to be coincident? Of course not. This one should be aligned with all the others, and the last one should be equal, meaning their sizes should match, but I don't want them to be equal. Concentrate means to make them concentric. You can see the relation has come up here. If we don't want to do this, another way is to drag this and place it here. It doesn't make much difference. It will cause a constant size to one of them. For example, a size of 10 millimeters. Now, in the Select control, I am actually selecting all of them together. The one with the size becomes the reference. And now I can apply the equal relation to all of them so that they all become 10. Now, I go to the feature and say I want a very small base like this. Of course, we are just practicing schematics here. It needs to be drilled and threaded inside these. We will continue to work on them together. The more we see it, the more it starts to look nicer. The more detailed it becomes, the more interesting our work gets. For example, I come back and select this surface. Then I draw a rectangle like this here. You might ask why I didn't normalize it this time. Well, I've worked on it so much that the lines on the surface have relatively decreased. How far should it go? You see, the blind state will perform whatever distance we give it. There are also other states here. Now I want you to get familiar with one of them. For example, up to surface. He says to tell him up to which surface. I say I want to reach up to this surface. Since I don't know its size, I say up to this surface. Of course, when we want to get familiar with something new, it's not necessary for you to fit it exactly because this is a solid shape. I've named it a profile. In fact, it doesn't really matter if you come here or there, because these are going to merge together. The tick is always on by default, unless I uncheck it, which I don't want to mention for now. This is also set to make it more robust. We can add more details to our work to make it prettier and more refined. We should also be careful that these details don't lead us to a point where you might not achieve your goal of keeping it very minimal. Certainly, adding too many details can take you away from your objective. I want to create an Extrude cut of 5 millimeters. You can see that it makes the thickness a bit more substantial. A logo should be, in our opinion, the more details we mention, the more we can refine the thickness. This was just an exercise, of course. We definitely need to add some other structures here or think about it, which is quite interesting. Maybe you've done this for many clients. They might say, "What kind of MDF is this that you've put on this table? It's very thick. How much did you put?" I say I put 6, and I remember. They say no, we should use 8. I say it's not a problem. I right-click on this 6 millimeter thickness I had set, and I change it to 8. Or they say no, change it to 12. It's fine, we can easily adjust our work. Don't forget to save your file so that you don't lose your progress. What I want you to practice is to create a test. How? A cube that has a bevel on each side. One side has a glass finish. 4, 3, 2, 1. We just want the kids to be very engaged in their work, and it must definitely be free-defined, meaning that for every piece they work on, they should draw the sketch with everything in black, and all dimensions should be provided accurately. This is our main term. You may have seen in the group that some of the kids have done other work. If you have done that, you can go ahead and create something like a chair or a table, anything you see around you. You can work with these same tools. I should also mention that even a simple pen or a simple drawing should be easier to create. You might not be able to do it with the book, but there are many other tools, or even your mobile phone. If you want to create something complex, you can also use your mobile phone. They are very good tools. Until the second session, and I will send you the video soon.